Yup! Good evening, everyone. It is Monday, June 23rd, 9:30 p.m. We're going to continue on today with some more coding, going into some more backtracking. I know it's been like only a day, but every single time I do one of these videos, it feels like forever since I last did a LeetCode. Like every single time I start one, it's like, oh my goodness, like, I don't know how I'm going to be able to do this. I feel like I haven't done one in forever, even though I literally just did one like 24 hours ago. And I've been doing one for like the past 26 days or so. I don't get it. I don't understand how the brain works like that, but, it's just how we do it. Anywho, we are doing 131 palindrome partitioning. So given a string S, partition this string such that every substring of the partition is a palindrome. Return all possible palindrome partitions of S. Oh, let me get a water real quick. Okay. This is kind of crazy. I'm not gonna lie, this is kind of crazy. This looks like a very hard problem. I'm not gonna lie. I'm kind of confused on like where to go with this. We have like AAB, right? Okay. AAB. From this, we can make a partition of like AB, and then like AAB, and yeah, that's all we can make. Okay, and then from here we can make a partition of like AAB, right? And AAB, but these are the same. These are equal. What the fuck? Dude, I have no idea. I don't even know, right? What the hell? What's the time? Dude, I hate these. Like, it's so exploded. Like, my lord, that's huge. I don't like. I was decent at understanding time complexity. Like, I know time complexity, but I was decent at like being able to read code and be like, yes, this is time complexity. But for these problems where it blows up to like the exponential time, it's like I never really messed with that in my schooling. I guess it's just practice makes perfect, But okay, so yeah, this makes sense. For given a string, there are 2 to n possible partitions. So 2 to the 3, what is that? 2 times 2 is 4 times 2 is 8. 1, 2, 3, 4, 5. I'm missing some. What am I missing? A, A, B. A, A, B. A, A, B. A, A, B. What am I missing here? 1, 2, 3, 4, 5. I'm getting cooked here. I don't. We can either partition and start a string or continue without partitioning. Okay. Wait, that makes more sense. Hold up. Actually, it's literally the exact same algorithm, brother. I like, jeez, why can I not just use my head? God damn it, dude. It's like always the exact same algorithm. I just like, I need to think. There you go. 4. What is n in this situation? There's 2 to n possibilities. Is there? I don't think there is. I think there's 2 to the n minus 1. Am I like chopping right now? Hold up. I'm actually curious now. Based off of my idea, there would be 8 here, which is going to be a lot to drop, but you know. Okay, that's 4. So there should just be one more layer. Yep, okay. Like a mosquito bite my foot. Or it looks like maybe a fire ant. Okay, so it's 2 to the n minus 1. Or n is the length minus 1. Oh, what am I doing? Yeah. We just gotta run the is palindrome thing on it. Is that like okay? That's the problem. It's like, is palindrome, that's an extra linear pass. There you go, leave me alone! God damn. Oh, this is much smarter. Wait. Oh, how would I do this? Oof. And this is actually cooking me right now. See, my lazy man approach was basically to like just grab all of these and then just do is palindrome inside each one, which is like that blows up. That is huge. Crap. But this is much smarter. But I don't want to do it. Okay. Okay, so in this instance, I should always choose to do the ignore step, but I should only choose to do the continue step if I have a palindrome. So, this is when J equals the end. So am I misunderstanding which one it is? When J is the end of the string. I mean, I think it's fine. I think maybe I'm probably doing this wrong because, you know, he wrote the code. He put it as J, so like I'm definitely doing it wrong in a certain instance. But we'll see. I'm just doing writing a quick little is palindrome. So basically just doing a two-pointer approach. Okay, there you go. All right, and here is the actual recursive function that we'll be doing. We're going to implement left index and right index. And partitions. I'm going to do like solution is equal to this. I'm going to do a non-local solution. Okay. And I'm going to do like if a right index is equal to the length of S minus 1, means the last one, I have two choices here. If is palindrome of S from left index to right index plus 1. Then I will say partition dot append this substring. Alright, I'll say substring equals this. Okay. And honestly, I kind of don't really like this approach. I feel like it's just too redundant, right? This just doesn't follow dry principle. What I'm thinking about doing is count. Do try count. Okay. Here you go. So basically I'm going to say if char count is equal to the length of S, then solution dot append partition. Else we'll just return. Oh, you know what? No, sorry. We should return regardless. Return. Okay. Beautiful. Okay. So substring is going to equal this. Then what we're going to do is our partition and then ignore. So we will only partition. So if is palindrome, right? Spell that right? I feel like I'm spelling that wrong. Nope, it's right. If is palindrome. So if it is a palindrome, then we can take it. Then I'm going to say partition dot append substring. Oh, you know what? Let's not do that, actually. Python's wonky array magic. Why am I blanking right now? We're gonna recursively call it. We're taking it. We're taking it. Left index equal. Nope. Right index plus 1. Right index plus 1. Partition plus substring and char count plus plus right index minus left index plus 1. Okay. Kind of like a lot, but you know. And if we're ignoring it, we're just going to do left index, right index plus 1 always, partition, partition, and char count. Okay, now we're going to run it. We're going to do recursion of 0, 0, empty array. Zero and return solution. Now, here's 3 ways it works. Okay, 3 ways this goes about. Okay, first way, this works and we're good. Second way, this works, but because of Python's array space, this causes an error. Third way, this doesn't work at all. So, okay. Now, hey, very good. Wow, that one was pretty cool. I actually quite like that one. Backtracking 2. Ooh, DP. Oh crap! I gotta get into my DP, man. I haven't DP forever. I hated DP. I guess what I'm doing is pretty close to DP. There's a lot going on in that one. Okay. Letter combinations of a phone number. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. Oh, wait. This is very interesting. Crap. Oh. Okay. Hope this works. This is how I do my stuff in whoops. No! No more debugging, no! Oh my goodness. Three, 4, 5, 6, 7, 8, 9. Perfect. Oh, you're joking. Some of them have 4. That's okay. Shouldn't be a problem. TUV. Oops. Oh, those are my forearms are cramping up. Ow. Fingers are cramping. Dude, I did back today. The lat pull downs fry my fingers, and they are not liking all this keyboard slamming. JKL. GHI. DEF. Okay. Bingo. Foin. Nice. Okay. I mean, is this really backtracking? Am I missing something? Because, like, you can kind of brute force this. No? I can kind of just say for I and T, and then for J and that, and then just do it. For... Oh, but it could be endless. I guess that's where the thing is. Okay. This one doesn't seem like it's a give and take, though. You know, like, oh, you either take it or you don't. Like, I don't know. It just seems like kind of like a bunch of for loops on top of each other. Am I tripping? We can use a hash map. Yeah. Think of this as a decision tree, where at each step we have a digit. We select one, multiple characters receive the next digit. Can you think of an algorithm to generate all combination of strings? I mean, like a nested for loop. We use backtracking where we select a character and process it, then backtrack to process another character. What? Are we using backtracking? Like... I guess, yeah, we can't do like a bunch of nested for loops. What? This is weird because it just seems blatantly obvious, but it's like there's a part that's like kind of disconnecting from this. Let's do like 2, 2, 3. Okay. Okay, so like let's say we choose to take and then ignore. So we choose to take, we take 2. Choose to take A. And then we can also have like index. So like I equals 0. Now I equals 1. Right? Dude, no. What? What am I doing? No. Hold on. No, there's a way I can do this. Hold on. Fuck. Why am I tripping on this, man? It's ridiculous. You do like... This is like ridiculously easy. What am I stuck on right now? I'm actually confused as why I'm stuck. Oh, maybe I was close. So I choose it. It resets. Let's do that. Choosing it resets. And then that sends me to the next one. So the next one is also A. I can ignore, which leaves me as like a blank, I guess. I think I got I equals 1. And if I choose to accept, then I get B. And then I go to the next one. Okay, this is oddly, weirdly challenging, somewhat. I don't know why. I actually can't point to the reason why. So I'm going to say number index. Number index. That's one of them. Got number index. We got letter index. We got word being formed. I thought we had one more. I thought I had one more. I don't. Okay. I'm just gonna continue on. Okay, so I'm gonna say if number index. Number index is greater than. Okay, hold on. No, first of all, I'm gonna do this one first. If letter index. Nope. Go to this one. Oops. Is equal to the length of digits. Bad. I'm gonna say greater than or equal to. Just hold our bases. Or. Phone of number index, letter index, return. All right, nothing happens here. You know what? Wait, hold on. If word length of word is equal to length of digits, and solution dot append word. Okay, that's what we're going to do it. So I don't have to do it anywhere else. And then I'll do a non-local solution. Okay. So that should work. Basically, if it's out of bounds, then we return. Okay, so I don't know if I haven't probably explained it, but number index represents the index of the digits. So you have 2, 3, so 2, 3, right? And letter index represents the index inside here, inside the array. This kind of gets more than I want. I think this is bad. Realistically speaking, if you'll have one question, it's probably gonna like blow up, or maybe not. I feel like with these huge like problems, like huge time complexity problems, like they can't blow up the thing if they wanted to because it's already blown up. Okay. And then I have a choice to take or leave. I can code it in that if it's the last digit, then it automatically takes. That way you just avoid the extra check. This kind of just adds an extra in. It's negligible. It's annoying, but it's negligible. Okay, so I'm going to say take, and I'm going to say leave. So for my take, I'm going to basically I'm going to say my number index is +1. I'm taking it. My letter index is going to be 0. And my word is going to be plus phone of digits of number index. What? This is so nasty. And then letter index. Yeah, that is something. Okay. And then to leave, I'm basically just gonna do recursive. Gosh, man. Sorry about that. Recursive of number index, and then letter index +1, and then word. Okay, and then what I'm gonna do is I'm gonna do recursive of 0, 0, 0, 0, empty string, and then I'm going to do return solution. Unknown network. What? What are you talking about? I'm connected, right? Oh my gosh. Why did they do this to me? Why did they do this to me? Why did they do this to me? Let's put this here in case. Dude, I hate LeetCode so much. I don't even remember my password. Dude. Let me live. God. doing that, man, actually genuinely pisses me off. What is this? If number of index is greater than or equal to digits. Letter index says letter index is greater than or equal to. I'm sorry, what's the problem here? Key error 2. If this is 2, then we just kind of like ignore this. Man. Alright, whatever. Dude, what do we... I'm so confused. What is the problem here? Yeah, well, two shouldn't... Man. Dude, wait, what do... I'm like, actually genuinely confused. Whatever, let's just run this. Oh, yeah, I mean, yeah, no, sure. That makes sense. Oh, my days. Is this what I have to do? No, sorry. Dude, I'm like... Okay. Okay. Yes. Okay, perfect. Right. So, the issue is... let's delete that. Let's just wrap this into quotation marks. Okay. Perfect. Alright. I'm gonna do all this work and it's not even gonna run properly. It's like, or sorry, it's not even gonna work. I keep doing Ymir without the B. Number. Okay. Really? Crap. You know what? I'm gonna cheat. I'm gonna do a little bit of a silly. I'm gonna say if digits is equal to an empty array, then return solution now. Strike me down. Yeah, that. It's not gonna run if I don't do equal properly. That's obviously not the best coding practices. I mean, yes, there are edge cases that will exist, but realistically speaking, your code should kind of take care of that. So, I mean, that wasn't the best, but it worked. So, I'll take the small W's I get. So, here you go. This is how they do it. If the length of the current string is equal to the length of digits, then the result is going to append the current string. This is way cleaner and way nicer. I like that. Definitely much better than what I did. Definitely much better. I like that solution. Very nice solution. But we're done. Let's take a peep at N queens. The N queens puzzle is the problem of placing N queens on an N by N chessboard, such that no two queens attack each other. Given an integer n, return all listing solutions to the N queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration and an N queen list or queue. Dot both indicate queen and an empty space respectively. Okay. Ooh, ouch, cut myself. Call me dumb. How do queens attack? Is it just like can they just go straight? Is it straight, diagonal, horizontal? Wait, this is kind of easy. Am I tripping? Wait, oh, the diagonal part. If it's diagonal, no, it's not easy. Yeah, if it's diagonal, it's definitely not easy. Well, there might be a way to calculate diagonal. Am I like 1, 2? Yeah, you can calculate diagonal. How do queens move in chess? Horizontally, vertically, or diagonally? Okay, so diagonal is the hard part of this problem. That is the hard part. But you can calculate that by like an is diagonal thing. So is diagonal would be, this is 0, 0, 1, and this is 2, 3. So the way we know this is diagonal is 2 minus 0 is 2. And 3 minus 1... Oh, sorry. Apologies. Okay. This is 0, 1. And this is 2, 3. 2 minus 0 is 2. 3 minus 1 is 2. So it's the same. Ergo, diagonal. So if you do the absolute value of them, then they are diagonal. This problem is, I think, actually is very self-explanatory. You place a queen or skip is how you would go about it. Place a queen or skip. And then you can make a special case if you're at the end and no queen is placed, then you have to place a queen. Place a queen, skip, place a queen, skip. That is your instance. Or you can do a for loop where you place a queen and then just jump across and see how that goes. Yeah. Okay. I'll do that tomorrow. I gotta go to bed. So, yeah. Thank you for watching. Appreciate. I'll see you tomorrow.